Yeah, hello everyone. I am Athar Chauhan, and today I'll be discussing two very powerful concepts in data science: feature engineering and statistical measures. My aim is to keep the entire session simple, practical, and easy to understand. By the end, you will see how raw data transformations into meaningful features and how statistical measures help us make smart analytical decisions. To be precise, this is our fourth question of our end same solution series covering part A and part B both. Part A for feature engineering, part B for statistical measures. So let's see what we'll cover today. So today, the first thing is the fundamentals of feature engineering, the heart of any machine learning project. Then four important techniques: encoding, scaling, and binning. Next, we'll walk step by step through some important statistical calculations. And finally, we'll understand where and when to apply each method. Let's get started. Now, what is feature engineering? Feature engineering is the strategic process of turning raw data into meaningful input features that improve model performance. If you think of data as ingredients, feature engineering is the process of cleaning, chopping, marinating, basically preparing everything before cooking. Without it, even the best algorithm cannot perform well. It bridges the gap between messy real world data and the clean structure machine learning models expect. Now, talking about the core operations in feature engineering usually involves four main tasks: cleaning, removing noise, fixing wrong values, and handling missing data; encoding, turning categorical data into numbers; transforming, reshaping data distributions; scaling, normalizing the ranges of features so they don't overpower each other. And these steps help us create features that our model can understand and learn from effectively. Let's discuss our first technique: one hot encoding. So one hot encoding is used when we have categorical variables that don't have any order. For example, if the season column has values like spring, summer, and winter, one hot encoding creates three new columns: season spring, season summer, season winter. This ensures that the model doesn't mistakenly assume any ranking or order between these categories. Now, technique 2: label encoding. Label encoding assigns number like 0, 1, 2, 3 to categories. This method is best when categories have a natural order, like low, medium, high. For example, 0 denotes sunny, 1 denotes cloudy, and rainy is denoted by 2. Now, the advantages of label encoding is simple, fast, and memory efficient consideration. It creates a numeric ranking, so we should avoid it for unordered categories because it can mislead the model. Now, we have third technique: feature scaling. Scaling is extremely important, especially for algorithms that depend on distance or gradient calculations. There are two popular methods. First, min-max scaling. This converts values into fixed range, usually 0 to 1. Second, we have standard scaling. This brings the data to mean equals to 0 and standard deviation equals to 1. Scaling is crucial for models such as KNN and SVM, neural networks, and anything that relies on distances or gradients. Now we have technique 4: binning or discretization. Binning converts continuous values into categories. This makes patterns more visible and reduces the noise. For example, age groups 0 to 18 can be termed as child group, 19 to 50 as adult group, and 51 plus as senior citizens group. Binning helps simplify complex data, handle outliers, and improve interpretability. So this was for our part A of question 4. Now let's discuss about part B. So, yeah. Now let's move to statistical measures. These help us understand the central tendency and spread of data. We will calculate mean, median, mode, and standard deviation on the given sample data set of the question, which is 12, 15, 12, 18, 20, 15, and 30. Now let's break each of these down. Mean, median, mode. Mean. We add all values and divide by 7. Sum is 122. When divided by 7, it gives us 17.43. Median, after sorting the middle value, is the fourth value, which is 15. And the mode, it's given that 12 and 15 repeat twice, so the data set is bimodal. Mode is 12 and 15. Let's discuss about the standard deviation now. Standard deviation tells us how spread out the data is from the mean. We compute each value's deviation from the mean, square it, sum them, and divide, giving us the variance of 33.67. Taking the square root, we get a standard deviation of 5.80. This shows moderate spread, and the value 30 and outlier increases this spread significantly. Now let's discuss the final thoughts. To summarize, Feature engineering transforms raw data into powerful predictive features. Encoding, scaling, and binning are essential tools in preparing data, also the labeled data. Statistical measures like mean, median, mode, and standard deviation tells us how the data behaves. Understanding when to apply each technique helps us to improve both model accuracy and interpretability.